Hey, Katie.
Hey, Ben.
So, as you know, I work in Facebook, and sometimes I feel like I'm lost at sea, swimming in seas and seas of data. I was wondering if this resonated with you and if you have anything for me.
Yeah, I got the goods for you. That's a
All
pun.
right.
You don't get it yet, but
Well,
it's a pun.
I, I'm excited to hear about this. You are listening to Linear Digressions. Now, interestingly enough, I'm actually recording from Facebook today because, schedules and everything. And I decided instead of going home and recording, here I am in a conference room watching people leave work through the
So
window.
we're a little bit crossing the streams here. So
Yeah.
we're talking about a project that is at Google. That they have a really interesting paper about the way that they organize data about their data sets. And the name of the system is
Data about their
Goods.
data sets.
Yeah. So we'll unpack a little bit more what that means. But I wanted to explain the pun
Sure.
before we lose the thread. So the pun is the name of their system is Goods. Haha. Okay. So the problem
got
that they
the goods.
have at Google is, as Google is kind of all about organizing and retrieving data. And so there's a proliferation of data sets that they have to deal with. I think in this paper, they mentioned 26 billion different data sets that they would potentially have to have on their radar.
That is insane. And although we're not talking about Facebook at all today, Facebook has the same problem of just having a lot of data. And, how do you organize that? How do you manage it? And actually, come to think of it, pretty much any company out there that works within the world of the internet or software or whatever, if they're doing things right, they're collecting a lot of data. And, they have to be able to figure out what to do with it and how to do things with it.
Yeah, and so if you're working on just like a one-off data analysis and it's just you and your CSV file, this isn't really an issue. But of course, if you're working with 26 billion data sets, that's usually a little bit more than you can keep track of at any given point. So the question is, how can you organize these data sets at a scale that can handle the size of the data that they're dealing with? And it's kind of funny, you said in the intro something about how there's an ocean of data. And I have in my notes here a line that, based on his vocabulary, I think might have come pretty directly from the paper, that they want to build a data lake, which is a place where data sets accumulate, and then provide tools that allow users to fetch those data sets back out when they need them. And so their goal is to build something like that, ideally in a way that's non-invasive. And so as the people are building and using these data sets, that they're just sort of being organized and kept track of in a very subtle way, so that the engineers don't have to actually change their workflows in a way to, for example, when they create a new data set, they don't have to register it anywhere. They don't have to add an extra line to their code to log it. They just keep doing what they're doing. And this system is kind of sitting in the background, watching and gathering the information and just taking care of all of that.
Yeah, big picture. A lot of times, if you want to organize something, you do have to do something very prescriptive and say, like, all right, anyone who wants to do this thing needs to do it in this way, right? But from my experiences at Facebook, you just can't do that. You've got thousands of engineers. You just can't make all of them do things a certain way necessarily. You need to kind of set up the systems so that way they're all kind of in the same ballpark. But yeah, you need to build systems that are both flexible and tolerant, because engineers are humans too, right?
Yeah. That flexibility, I think, is one of the most challenging things. And one of the ways that they sort of brought that under control, from what I can tell, I'm not an expert in this as much, but it sounds like there are these things that they use called protocol buffers. And I'm not sure that this is just a Google thing, but again, I'm not an expert. And it sounds like these are basically standards that they have for themselves about how the data is going to be structured. So a simple example is, if we have a piece of data about a car, like car usually has things like make and model and maybe license plate number and color. And so then every time that you have a car, you have a reasonable expectation that those columns are going to show up, and that you can, potentially like merge data sets based on that. You can impute what kind of, if you see a line in a database that has those attributes, but you don't know what kind of data it is, you can make a reasonable guess that it's a car. So the fact that there's a fairly limited number of these protocol buffers that tend to span a lot of the data sets, I think helps them out a lot in making assumptions about what formats the data might have.
I just have to say two things. First of all, protocol buffers are indeed a Google thing. They are the developer, but it's also open sourced. So really, anyone can use protocol buffers. This technology is open. But what's funny is I was actually at a wedding just 5 days ago, and I was talking to a Google developer, and he's like, "Man, have you heard of protocol buffers?" And he starts explaining what they are and how they work and everything. It's just really funny that this would come up just a couple days later.
Oh, did I get the explanation right?
Yeah. You at least as I understand them. I haven't really looked into them either, but yeah, it sounds right to me.
Okay, good. That's reassuring. There are many challenges besides having to handle many different protocol buffers, though. Some of these things I hadn't even thought about, but as soon as you think about it, it makes a lot of sense. Sometimes you have data sets that will be distributed over many files. I know this happened for us a lot in physics, where it doesn't make any sense to have just one file that has data in it, but instead you're going to do something like chop it up so that each file is of a reasonable size, and that if one of them, let's say, gets corrupted, then you only have a small piece of your data that has a problem. How do you take into account the fact that you might have a data set that's all over the place? And the heuristic answer to that is you look for data sets that usually are stored in the same place, or they have similar sounding names and things like that. But you want to have the goods, the organizational system, needs to know about those kinds of heuristics and to interpret it the right way when it sees a bunch of files that have sort of almost the same name. And that can take many forms too. Like sometimes you'll have data sets that are basically the same data, but they're in different levels of processing, or there's data that gets recollected every day. And so you have a stack of files and each one has a different date stamp or time stamp on it. And so understanding those relationships that you can have amongst the data sets themselves is a major part of this. And I'm getting a little bit ahead of myself. Another challenge is that the data sets churn. This data is not just sitting there ambient and ready for you to crawl over it. That they said they have about a 5% churn each day. 5% of their data gets deleted and replaced. And so
wow.
Yeah, so dealing with that, being constantly watching things and being able to update things very quickly when you sense them changing is also very challenging. It means that this needs to be fast. And then some of the most interesting and high level and maybe challenging questions are a little bit higher level. Things like which data sets are the most important and what is the meaning of the data in each of the data sets? Because these are the things that I would really care about as a user, trying to have a sense of the many different options that might be available to me if I'm looking for, let's say, a data set related to Gmail. There might be one big data set that's really important and a bunch of other data sets that look kind of similar, but they're, people's development versions of other kinds of little test data sets or something like that. Being able to find sort of that central data set and return it to me quickly and not have me wasting my time clicking through everybody else's, scratch space, basically.
So basically trying to figure out what's important of all of these things and what's less important. So it can kind of rank those results. Right.
And to help me, once I find something that seems like what I want, give me some tools that help me interpret what the meaning of it is. For example, the protocol buffer thing I was talking about before. If we see make and model, then this is probably some kind of car data set or whatever. So there are a couple big pieces to this catalog that they've made. One is building a tool that clusters or groups the data sets. So that deals with things like we have a new data set in the series that gets produced every day, or we have a data set that's distributed over many different files, that you have a part of goods that is aware of the fact that there might be related data sets and looking for some of those relationships so you can tie things together. Another thing that is really important is understanding the provenance of data. Have you ever heard this term, provenance?
Provenance?
Provenance.
Provenance. No, I've not heard this term.
Okay, this was something I used to hear in physics sometimes, but I think it's a more general term than just physics. So provenance is the idea that you have a data set and it's kind of traveling through some kind of analysis pipeline, let's imagine. And so you have maybe the raw data, and then it gets cleaned up a little bit, and then it gets transformed, and then it gets, maybe transformed again. And so understanding the relationship between the chains or the links in that chain is kind of what provenance is about. So for any given data set, it says what data set did I come from and what data set are downstream of me, so that if you have a change anywhere along that chain, you have an idea of how that's going to propagate downstream, and if a job crashes, what other jobs are going to be affected, those sorts of things. So being able to infer those kinds of relationships either from the data, sometimes from the code, that's what provenance is all about. And so you can see how that can be really important for understanding these relationships.
So I just actually looked it up, and Wikipedia says that provenance, from the French provenir, to come from, is the chronology of the ownership, custody, or location of a historical object, but it's been generalized for use in computers pertaining to both the ownership of data and also who has accessed the data over the course of the data's existence.
Cool.
I love when these technical terms have actually long histories, but as people in the tech world, we experience these terms all the time, and we even use them all the time, but we don't realize wow, this comes from archaeology and paleontology and whatnot, and until you look it up, it's kind of fun.
That's how you end up wasting an entire, well, not wasting is the wrong word. That's how you end up spending an entire evening on Wikipedia sometimes. But we digress.
Yeah, it's a dangerous place.
So one more thing I want to add about this is it sounds like there's also the capability within most of the Google data storage systems to attach user annotation to data sets. So you can go in and say this is my data set for the project that I'm doing about classifying different types of irises relative to each other or whatever. And that can be really helpful, obviously, just as keeping notes to yourself or to other people who might use the data set. But that's something that Goods also relies on fairly heavily. One of the things that's interesting about annotated data is the fact that a human has annotated it is a big hint that it might be important. And so when Goods is going in and trying to think about the question of which data sets are the most important, it's going to look for data sets that have a large fan out below them. So this data set is the upstream, one step upstream of many, many data sets. So it means it has many child data sets. So that's a clue that it might be important. And then one of the other clues that it might be important is that if it has one of these human annotations attached to it. And so that's sort of the other part of Goods, is not just gathering all this information on the data sets, but then trying to turn it into something that the user can think of as almost like a search function or something like that, that they want to just figure out very quickly and very easily which data sets are going to be most important, and then go in and retrieve those.
As we've been talking, this all sounds kind of familiar. It sounds so we've got a huge amount of data that we need to organize, right? Not necessarily by what the data actually is, but by the data about the data, the metadata. Is this important? For what reasons? All that stuff. You've also got a way of querying this to figure out what data sets are the ones that I might be looking for if I'm looking for some data. This sounds like web search, but with data rather than the internet.
I think that's a really interesting point, because one of the things that struck me as I was reading this paper, it's a really good paper, but it's clear that the system is nowhere near as sophisticated and easy to use and things like that at this point as web search is. Web search is it's a box and you type in the thing and it works, and it, this is exactly what Google does so well. And so the idea that they're still kind of figuring out how to do this with their own data sets was actually pretty striking now that you bring it up. They've done incredible work. I don't want to make it sound like, this isn't impressive or anything like that, but it's clear that this is a problem they've been working on for not nearly as long as the web search problem. But you're right, it feels structurally very, very similar.
Yeah, one can only hope that the world for us developers and data scientists will one day be as easy to use as the consumer with Google. Linear Digressions is a Creative Commons endeavor, which means you can share or use it any way you like. Just tell them we said hi. To find out more about this or any other episode of Linear Digressions, go to lineardigressions.com. And if you like this podcast, go ahead and leave us a review on iTunes so other people get to listen to this content too. You can always get in touch with either of us. Our emails are ben@lineardigressions.com and katie@lineardigressions.com in case you have comments or suggestions for future shows. You can tweet us at lindigressions. Thank you for joining us, and we'll see you next time.